So in this question, it's find the area of the region bounded by the curves y equals excuse me, y equals x squared minus 1 comma y equals negative 2 x plus 2. So you can see I drew the graph here, and we're trying to find this region right here. So what I do is use this formula right here, and it gives us a to b right here. So basically this, I try to find which one's the upper, and then this is the lower. So I try to find these two. So that's why I do the graph to see. You can clearly see here, this is higher, so this would be first, and this would be second. And plug it in here, plug in this here, and you can see that you could just use FOIL method. FOIL, which is like basically this to that and this to that, and you get this. You find the integral, which is this answer right here, and then you subdue b minus a, which is this right here that I'm showing right here, and it'd be 13 over 6. Same thing here, find the area region bounded by the curve, this curve. Y equals square root of the cubic root of x minus 1. Y equals x minus 1. We're trying to find this tiny right here. This right here. So what you do, find which is upper and lower. You can see that clearly this line is upper, and that one would be this one right here, and this is lower. Plugged it in like that, you can see that these cancel out, because anything to the power of anything of 1, or 1 to the power of anything is always 1. And then you find a derivative of these two, which would be right here. This is the answer. Then you plug in these two, and clearly see that it's negative 1/4, which is pretty accurate. Number 5. Oh, by the way, this is only activity 29. Find the area region bounded by the curve y equals cosine of x, and y equals 2 of x, 2 minus cosine of x, and then this is a and this is b, just in another way given. So you see that here you find which one's upper and which one's lower. This is I think this is regular cosine, and this is the minus 2 1. So this one right here, you clearly see the line that's upper here would be just 2 cosine x, and what's lower is cosine. So I plug it in. So you see that this equals this here. When you plug these two together, it'd be 2. I did this just in case to prove my point. When I found the integral, found the integral and plugged this in, you could see that the answer would be 4 pi. Now number 7, area of 2 regions. So it gives us 2 y of 1. Well, y1, the first y is 3 parentheses x cubed minus x, and this one is 0. What I did is I found this here, which is basically 0. Basically, I did the same thing here. I'm basically plugged in y as well, and I try to find x, and you can see that the x that we got is this one, obviously plus or minus. So find the integral of that, and I never really finished doing this one, but what I did is found the integral, and it goes from negative 2 that basically. And since this is an even function, you could just use the formula even, which is 2, or yeah, a2 f of x, and then you can find the answer, which is what I would do here. But this is not part of the 12 questions that I chose, so that's basically what you would do when you found the area. We keep going to learning activity 30, and it says find the volume of the solid generated by revolving the region bounded by the graph of the equation y equals minus x plus 1, y equals 0, x equals 0, about the x-axis. So this is the formula. This is the formula given. And you can see that we have this right here. This is f of x. I put it here and I revolved it by the x-axis. So basically finding this right here. Then what I did is I squared it because this is in the formula, and I got this right here. Then I found the integral of this, and I got then I have to plug this in, which basically is you know, it cancels out here. 1 over pi, you know, that all that this cancels out, and this is 1/3 pi. This here, number 3, is find the area of find the volume of solid generated by revolving the region bounded by the graphs of equation y equals 4 minus x squared over 4, and y equals 2 about the x-axis. This one I didn't draw a graph because all I just needed to do is input the equation because it's a washer method. Not this method. Why? Because there's 2 different y's. That's why. So I basically try to find the x, which is right here. Which is right, sorry, I didn't point at it. This is x, but my apologies, I didn't put it here. But let's see that it's there. Then I plug it in here, find the integral, and they gave us this answer right here. This is a lot of canceling and stuff, and then you get 4 pi, and you plug in the numbers, and it gives you 16 square root of 2 pi. Number 5 is also the disk, but rotated about the y-axis. Basically, you just find the inverse of everything and find what x and y are. I found here, and then I found the integral here and put this formula in here. You can see that I found the integral right here, and then I plugged it in, and you can see that I ended up with 256 pi over 6. And number 7 is y equals secant of x, y equals 0, and 0 to 1 to pi over 3. This is A, this is B, y equals 4. And now it's giving us a specific line. So what I did is just I basically found the integral of secant, which is of secant squared, because when the formula, like I mentioned, is it's this with this. So put in the square, integral of secant squared is tangent. Plugged in the tangent, the numbers on the tangent, and we get this right here. This is the graph, so you have an idea. Now this is the disk method, where we use to find the method to verify the volume of a sphere, which is 4/3 over pi r cubic. So basically what I did is I used the Pythagorean theorem right here, and then I made it into equation f of x, plugged it in here, try to find the integral. This is the integral right here, and the a and b is r to 0. Plugged it in, show the integral, plugged in the r's and the zeros, and you can see that I landed this right here. Then yes, that is everything. Thank you.